Welcome back, and this is the last in the series of videos looking at these redox titration and the redox titration calculations. In the last video we looked at the manganates, and in this case we're looking at titrations that involve iodine and iodide, usually with thiosulfate. So these ones are slightly more complicated, but what we're going to do is in all cases, or most cases, we add an excess of iodide to a known quantity of our oxidizing agent. Now what that will do is it will produce some iodine. So these reactions always come in two parts. The first part, we add our excess iodide to our oxidizing agent to produce iodine. We then do a titration with sodium thiosulfate. What the thiosulfate will do is it will measure the amount of iodine that has been made, and we can then work backwards to work out the amount of our oxidizing agent we needed to start with. Now this equation comes up a lot, this reaction of thiosulfate and iodine. You also might remember it from your iodine clock reactions we did in kinetics. So it's a really useful reaction to learn. So in our first example, we've broken it down into steps for you. Now in the exam, you wouldn't normally have all of these steps. You would normally be expected to work this out without the scaffolding. But for the first example, we're going to go through this with the scaffolding. So I've got some household bleach which contains sodium chlorate, to which I've added excess, again, remember it's in excess, potassium iodide, and that's produced some iodine, and we've taken that iodine and we've titrated it against our thiosulfate. Now because we've added the potassium iodide in excess, the amount of iodine that we've made is directly related to the amount of chlorate that we started with, because these two are in excess. This is my limiting reagent. So the amount of iodine we've made is limited by the amount of chlorate that we started with. So again, typical kind of reaction, you read them forwards and work them backwards. So we're going to first of all work out the number of moles of thiosulfate used in my titration. So I've got my volume and I've got my concentration, so I can work out my number of moles. So I have moles of thiosulfate is volume, 18.5 divided by 1,000 times my concentration, which is 0.2, and I get 3.7 times 10 to the minus 3. Now the molar ratio of thiosulfate to iodine, so thio to iodine, is a 2 to 1 or 1 to a half. So therefore the number of moles of iodine is half of this value. So that would be 1.85 times 10 to the minus 3. But the molar ratio between the iodine and the chlorate is 1 to 1. So therefore moles of chlorate, OCl-, is the same number, 1.85 times 10 to the minus 3. And do remember that was in the 25 centimetre cubed portion. So we're now going to calculate the concentration of the diluted bleach. So the concentration is equal to number of moles, 1.85 times 10 to the minus 3 times by 1,000 divided by the volume. Well, the volume in this case was 25. So we get a concentration of 0.074 moles, dm to the minus 3. But we diluted that from our 25 centimetre cubed sample by a factor of 10. So the concentrated bleach is 10 times as concentrated as the diluted bleach. So my concentration is 0.74 moles, dm to the minus 3 of my concentrated bleach. So the last example on page 9 is far more typical of an exam question. So you're asked to find the percentage by mass of copper in the sample. You're given the equations that you need to work that out, and you're going to be given a lot of blank paper to work it out. So this would typically be a 5 or a 6 mark question. Again, you need to read this forward but work it backwards. So the first thing I'm going to do is I'm going to work out the moles of my thiosulfate, and that is equal to my volume, which was 23.7 divided by 1,000 times by the concentration 0.48, and that is equal to 1.1376 times 10 to the minus 2. So I've got my volume, I've got my concentration, work out my number of moles. So my moles of my iodine is going to be this number divided by 2. Divided by 2. And that equals 5.688 times 10 to the minus 3 moles. I can now have to relate that back to the previous equation. So the moles of copper, Cu2 plus, and if you look at the equation, it's a 1 to 2 molar ratio. So it's going to be this number times by 2. We're kind of back to where we started from, but it's still important that you go through the steps so you show the examiner that you understand all these molar ratios. So I've got my moles now of my copper 2. Okay, so I've got my moles of copper 2. Well, copper 2 to copper is a 1 to 1 molar ratio. So I can now work out the mass of my copper, and that's my moles, 1.1376 times 10 to the minus 2 times 63.5, and that gives me 0.72 grams. So the percentage by mass, 0.72 divided by 0.877 times by 100, and that gets me 82.4% by mass. So that is my answer. Notice in this one, though, you don't have a dilution effect. Quite often in this, you would have to times up by 10 at some point for a dilution effect. And that finishes this short video just looking at the thiosulfate iodine reactions and the redox titrations using these ones. You're going to practice the practical in class, and you're going to be given lots of worksheets to work through these calculations. So until next time, take care, stay safe, bye-bye.